So we have learned like some different AI tools for teaching sciences. So today's topic is about AI for chemistry. So chemistry, we call it as generally we call it as a central science because it connects different concepts of physics, biology, technology, even with our everyday lives. And this chemistry is used to help us understand the behavior of matter, like each and everything, from the air we breathe to the food we eat, everything it helps us to understand, because whatever we do, that will be in the form of atoms and molecules. So for that reason, chemistry plays a very important role. So today we will look at the tools which are used, the AI tools which are used to learn the chemistry. So first tool is of Avogadro. So this is the first tool. So for this tool, we need to install it from the Google. This is an open source. So this Avogadro tool is an open source, a free tool. So for this, we need to go to Google. Here you need to search like Avogadro. So click on Avogadro. So here you can see the URL like http avogadro.cc. Click on this. So this is an like a free open source molecular editor and a visualization tool which is used to make the chemistry concepts like much easier to learn and explore. So how to use this tool is, first we need to download this. So click on download option. So here you need to click on download option. Actually, I have downloaded this. I'm clicking the pause option for showing you. I have opened this. So you need to click the download button. As soon as you click the download button, it starts downloading and it will show you here, like as soon as it gets downloaded, it will show you here. So we need to open that, and you need to click on next. The buttons will be of next, and some privacy agreement will be there, like you need to click on I accept, and we need to finish that. So as soon as you finish that, it will open, like I'm searching in my search bar Avogadro. Already I have installed this because it is taking more time to get installed, so I have installed it. So now this is the page of this is the page after we install. We need to open that. You can see this type of this is the menu, which, like, 1 minute I'll show you. See here, you can see here Avogadro. This is the symbol which you can find A with a molecule surrounded, with a symbol of a molecule surrounded by the A. This is the the icon which will be appeared for you as soon as you complete the download option, and you need to click on that Avogadro application. So as soon as you click on that, this page will be opening for you. So in this page, we have different types of options like a file, edit, view. So each and everything I'll explain. So first option, in order to do this task, or like as I told you, this chemistry is also called as a central science because it is a combination of physics, biology, etc. Even technology also combines in this. So here each and everything is considered as a molecular or an atom. So for that reason, this chemistry, each and every particle, you need to explain that in the form of an molecule or in the form of an atom. So first thing, after downloading, you need to open the application. As soon as you open the application, you will see this type of a blank workspace. So in this blank workspace, so we need to we need to build the molecules which we want to show or which we want to visualize. We need to we need to place that molecules in this blank workspace. So for that, we need to have a look about all these options. So first thing, to build the molecules, here you have a tool. Here in this, you have a tool in the form of a pencil. See here. Sorry. So this is the tool which is used to draw or place any molecule which you want. This is called as a draw tool. That is in the form of in the shape of a pencil, that is. So you need to select this draw tool. So when you select this, as soon as after selecting that draw tool, here you have this blank workspace. No, in this blank workspace, you need to click here. See, as soon as you select the pencil tool, this pencil tool is also called as a draw tool. So I have selected that and I have clicked in this blank space. So when I clicked in this blank space, I have got a molecule. I have got some default. Here the default molecule or default element will be carbon. Here you can see we have in this draw settings, there is an option called as element. In this element, we have a default molecule as carbon. So as soon as I select this draw tool and paste it on this blank workspace, we are getting a default molecule as carbon, and we are getting even molecule as a H hydrogen. So why I'm getting hydrogen is here I have an option called as adjust hydrogen. That adjust hydrogen checkbox is enabled. So that's the reason as soon as we do that, we are able to get that hydrogen also. So I'm disabling that, and now I'm clicking here. See here, only when I click now, I'm doing undo option. See, I have done all the things undo. Now I'm taking the pencil tool and I'm clicking here. See, only I got a molecule of only carbon atom is being displayed. Why? Because here the default element is carbon. And if you want different types of elements, then click on this drop down option. Here you have different types of elements: hydrogen, boron, carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, bromine, and other. So other than this, if we want to use any elements, then we can click on other option. Then a periodic table will be visible for us. So from this, whatever the element we want to use, then we can select that and we can use. So for example, I'm using this and I'm clicking here. See, you can see here this molecule is being placed in this blank workspace. So this is how we need to place an element in this blank space. And now if you want to change this elements, as I told you, in this elements you can click and you can insert that. Now if you want to insert any other element to this nickel, here I have taken the nickel from the other, I clicked here other, and in other I have got a periodic table. In this periodic table we have all the different elements. So in that I have selected the nickel, and in that nickel I have as soon as I select that, here I have placed this in the blank workspace. Now For this, if you want to bond any other element, you can click here any other element what you want. I'm clicking on oxygen here, and that oxygen I want to bond with this carbon. So you can click here. So you will be getting this. You can click here. Just if you click on that with your left arrow, if you click on this, you can attach, you can bond any other element to your existing element. Just you need to right click. You need to just right click, and if you drag your other element what you want to attach, that will be attached to that. And here the bonding is of between this carbon and oxygen, the bonding is of a single bond. Here here you have a component called as bond order. So in this bond order we have options like single, double and triple. So we have by default single option is being chosen. So as soon as I want to bond any other element, so directly I am getting the single bond. So if you want a double bond, then select double here and click on this bond. Then you are going to get the double bonding here. Just click on this bond, then you will be able to get the double bonding. In the same way, if you want to get the triple bonding also, just select the triple and click on this. Then you will be getting the triple bonding. Just click on the link between the two elements. So what is the link we are having? Just click on that link. You will be able to get the bond, which type of bond order you want. That bond order we can get. So this is how we can build the molecules by using this tool called as a draw tool. That is also called as a pencil icon, as it is in the shape of a pencil. We even call it as a pencil icon. So this is how we build the molecules. Now, for example, we will build the water molecule. So the water molecule, the formula for the water molecule is H2O. So the formula for the water molecule is H2O. Now I'm going to this tool. I'm doing this control Z undo. I'm doing because I will place the water molecule. Now I have got the blank workspace. Now I will be drawing the water molecule. So the water molecule, the formula for the water molecule is H2O. That means we need to add one O atom. O is nothing but the oxygen. So I have selected the element oxygen here, and click on this draw tool. Then click in the blank workspace. So I got here O, and next is we need to attach two H molecules or H atoms. So H, I'm clicking on hydrogen here. So directly we have here hydrogen. No, I'm just enabling this adjust hydrogen. So now we need to draw two hydrogen molecules. Sorry. So first is oxygen, and the next I need to draw the hydrogen. So hydrogen. So hydrogen I'm drawing here. I'll use a single. So done. I have drawn one oxygen atom, and I have attached two hydrogen atoms by using single bond. So here I have built a water molecule, and here you can see here this in the display types to your left hand side, here you can see display types. In this display types, we have different options: axis, ball and stick. I'm disabling all this. If we click a ball and a stick, then this will be visible for us. The atom and the bonding with the different atoms will be visible for that when we enable, or when we enable this ball and stick options. That is, it renders the primitives using balls and sticks. Balls are atoms and sticks are the bonds. And now, if we want to know the names of these atoms, then you need to enable here the label. So this label will tell you about the atom and the bond labels. So see, previously we did not see this naming. Now you can see the names of these atoms. Here this red color atom is named as O, that is oxygen. And here this hash color atom is named as H1 hydrogen and H2 hydrogen. That is two molecules I have taken of hydrogen, because I want to draw water molecule, that is H2O. So I have taken two hydrogen atoms and one oxygen atom. So it is showing as H1 and H2. So these are the different visualization tools which are available for us. These tools are called as molecular visualization tools. So in this molecular visualization tools, I have different types of tools like axis. So if I click on axis, and ball and stick, if I click on ball and stick, it will show like this. If I disable that, only you can see the atoms. I hope it is visible for you. We can see only the names of the atoms. Our like the atoms, the shapes are not visible for us. Only the labels are visible for us, like O, H1 and H2 are visible for us. So to make it visible, to make it visualize in with the forms of some like in the form of some shapes. So here we have a tool called as ball and stick. So if you enable that, we can see the like the molecules which we have taken. There will be some shape for that. And the next one is, if you click on label, the labels will be appeared. If you disable this, the labels will be disappeared. So I am enabling this label. And a ring, this will be for different, like if we take more number of things. Now I have enabled the stick option, so the representation have been changed. It will like the representation have been changed. And see, I have clicked this van der Waals spheres. So the representation has been changed into this form. If you enable that, I have disabled that. Next, wireframe. So these are all the molecular visualization tools which we have in order to visualize. And here, apart from this draw tool, after this we have the navigation tool. So if you click on this navigation tool, and if you click on this atom, you can rotate this atom. You can visualize, you can show this with the help of visualization by using this tool called as a navigation tool, which is in the form of like in the shape of a star button. No? So that is called as the navigation tool. If we click on that, and if you select this, whatever the atom you want to rotate, just click on that, and you can rotate it 360 degrees, whichever degree you want. You can rotate it and show. So this is how the use of this navigation tool. And the next tool we have is bond centric manipulation tool. So I'm clicking on this. This is used to show the degree between these atoms. See here, here you can see, I hope this is showing as 90 degrees. So this tool, like what is this bond centric manipulation tool? This tool is used to show the angle between the angle between the bonds or the length between the bonds. You can check by using this angle by this bond centric manipulation tool. And the next tool we have is manipulation tool. And the next one is the selection tool, that when I draw that I'll show you. When we draw the fragments and atoms, we can use that tool. And the next tool is auto rotation tool. So if you click on this auto rotation tool, as soon as I click on that at auto rotation tool, to my left hand side I got an options like auto rotate settings, X rotation, Y rotation and Z rotation. So here we need to click on start and adjust this. See, directly auto rotation of our molecules is been happening by using that. So you can adjust this in our settings, X rotation, Y rotation. You can adjust this so that the molecules will move in like auto rotation will happen by using that. If you want to stop, we can click on stop. So this is the use of this auto rotate. And auto optimization tool. So this is used to optimize our molecules. So if you click on this, that is in the form of E, like uppercase E alphabet we have. So that is called as auto optimization tool. So here what happens is auto optimization of tool happens. So here we have some settings here, auto optimization settings. In this we have the force field like GAFF, chemical, MMFF94, MMFF94S and UFF. So UFF is selected by default and click on start. Then here our molecule is getting optimized automatically, and here it will show the values to what extent it has been optimized. You can click on stop button, then the optimization will stop. So this is the use of this auto optimization tool, and this is used to measure. I will show you with an example. So this is how to like build the molecules, how to insert the molecules, or how to draw a molecule, or how to insert a molecule into this tool. And here we have different so we have explored the major things in this. One is the draw tool, and the other is the navigation tool, and the other one is this angle tool, like a bond centric manipulation tool. Now I will show you here different options what we have. And here this in the file, as we have in our MS Word, Excel, we have the file option here. In that you have again new, open. The new in the sense a new blank space will be opened for us. Open, our saved options will be opened here, and save as, etc. This all we know. And edit we know, and next new. And in new we have some options like center. If you click on this, the atom will be placed, the molecule what we have what we want to do will be placed in the center of the page. That is the use of this option. And the next is full screen mode we know. And the next is a build option you have. And in build option, insert, Control Z, 1 minute. I'm taking the fresh page. Control Z I'm doing, just undo. Now in build page, I'm going to insert, and in insert we have DNA or RNA, fragment, smiles and peptide. So now first I am going for DNA and RNA. So here I want to insert one DNA or RNA with the use of this nucleic acids. So we have A, C, G, T. So here in which order you want to place that molecules, you can give the sequence here. So I want A, C, G, T. So in this order, I want the molecules to be placed. And here bases per turn, here we have again options A, B, Z and other. So I'm going with the default values B, and here I'm going with the default value of 10.5. And how many strands we want? Either we want a single strand or either we want a double strand. I'm selecting with the single strand and click on insert option, then close this. So you can see here view center. See here, now you can see here the molecule, the DNA has been inserted. I'm zooming here, the DNA has been inserted here. Now I'm clicking on this navigation tool and you can see here our molecules are being rotating. Our molecules are being getting rotating, and now I'm clicking on this angle tool. So here that is not clearly visible, but here you can see in the light, like here it is showing 109 degrees. So between the length between the molecules can be shown by using that. So the length between this DNA molecules is, it is showing 109 and all. And you can auto rotate this. So you can auto rotate this DNA molecule. So you can visually explain the shape of DNA, how the DNAs will be and what all the molecules will be in the DNA. The molecules are being labeled here. We can clearly visualize and explain this. And the bondings between each and every molecule is also shown here. There are some single bonding molecules and double bonding molecules are there. I'm clicking on stop. So this is how we insert a DNA, and here one more option. So here we have the manipulation tool. This manipulation tool, here you have this x-axis, y-axis and the z-axis. So you can either increase this values or decrease. I'm increasing those values all to 6. Previously it was to 0. I'm increasing it to 6. And now I'm clicking on apply. See, now here our like the size of the atoms have been increased. You can again, I'm like keeping it to 0 and click on apply. So here our molecule size has been decreased. Reset. Rotate around geometry. 4, y-axis 4 and z-axis 4. Apply. Rotate around origin. Apply. So here you can do this manipulation settings by using this tool, like manipulation tool. This is used to drag the atoms, move the atoms, like move further and closer by using, like by changing the values. If you want to make it more closer, we can use that 0, 0 by default. If you want to increase the size, like if you want to make the atoms far away from each and every atom, you can increase the size and you can click on the apply option. This is how the DNA looks like. And the next is build and insert. We have here again fragment. 1 minute, I'll make it I'll take a fresh page. Here, build, insert, fragment, and in fragment, you can select for anything here, like fullerenes I'm selecting. And in fullerene, some CML file, insert. So here the fragment has been inserted here. So this is the fragment which is being inserted, and here if I click on label, you can see on a different like atoms what we have in that fragment. And the next one, so here I have clicked on click to measure. See here, I have clicked on this align, and this align, you can align every molecule, everything, or align molecular wise align. So you can see here the molecules are being aligned. Previously when I clicked, all were clumsy. Now you can see all the molecules are being aligned in a, see here in the circular way. You can clearly visualize here. Each and every molecule is aligned. See, you can see the difference. Each and everyone is clumsy, but when we click on this align, and you can see now each and everything is been clearly visualized by different atoms are there, and those are with different colors. So clear visualization is being here. And here I'll show you wireframe. So auto rotation of these molecules happens. You can increase the speed or decrease the speed. All in different X rotation, Y rotation, and Z rotation. You can show the rotation of the molecules and you can explain. So this is about fragments. And next we have here smiles. 1 minute, I'll again undo this. Again here build, insert, smiles. So for this smile, if you want the smile fragment, you can go to Google. You can go to Google, and here you can search like chemical identifier resolver. So chemical identifier resolver. So in this chemical identifier resolver, what we have, what we want, which structure we want, we can give. For example, I'm giving as a phenol. Submit. Here we need to click on smiles, submit. So this is the like the identifier name of that chemical. So this identifier or this name we need to copy, select, right click, copy, and go to this Avogadro tool, paste here, and click on OK. One minute. Avogadro. Build, insert, smiles. So I'm inserting this. Okay. So this has been inserted into this, and you can perform the different types of like the rotation and different things what we can do. You can perform the same as we did previously. That is about smiles. And insert peptide. So what peptides, like what, with what amino acids you want to insert, we can insert here. Like file, new. Sorry. So with what amino acids we want the peptides to be built, you can click here, like ALA Pro, whatever you want. I'm just clicking on this. With this sequence, our peptide will be built. I'm just giving the sequence, with what sequence I want my peptide to be built. So I'm inserting this. So you can see here with what all molecules I have selected. View, center. So now our molecule has been brought to the center. See here, with what all I have given, build, insert, peptide, with what elements I wanted in the sequence only, my peptide has been created, and the structure is also in the form of straight chain only. You can see here, the structure is in the form of a straight, in the form of a chain, a straight chain, as I have selected there, that. And build, insert, peptide, straight chain. Here you have some other thing, no? Some I am selecting alpha helix, insert peptide. Now you can see the difference between the straight chain and this alpha peptide. See here the difference. This like in a different format it has been inserted. So with this like label, all the atoms are being labeled and been shown. So this is how we insert a peptide, and you can find the angle between this. See here. The angle, it is not clear, I think so. It is showing 90 degrees, it is showing. I'll just zoom and check once. See here, it is showing the angle between this. Now, I have inserted the peptide. Now I'm going to file, and I'll be saving this. Save as something I'm saving, like some chemistry. Chemistry I'm saving. With the .cml extension, we need to save that. Desktop I'm saving. Save. Now, file, view. In the view, click on properties, molecule properties. If you click, see here, in this molecule, what we have taken here, the molecule, in this molecule what we have taken, this I have saved as chemistry molecule, no? So that molecule properties will be shown here. So the molecular weight of this property is this, and the formula, with what formula we have created this is this C86H130N22. This is the chemical formula of this molecular structure. And here the number of atoms used in this molecular structure is 264, and number of bonds used, the bonds between each molecular we can find, no? So that number of bonds are 268 and number of residues are 16. So in this way you can give the molecule properties of your atom what you have created. Click on OK. Next, view properties, atom properties. So now these are all the atoms which you have used in that structure. We have used how many atoms there? It has shown, no, the number of atoms which we have used. The atoms which we have used is 264 atoms we have used. So the element name of that, the type of the atom, the valence and the partial charge, and this X, Y and Z, all these atom properties will be shown in this atom properties menu. So in this way we'll get the atom properties, and again view properties, bond properties. So we have the bondings, no, between each and every molecule. We have the single bond between something, some atoms, and double bond and triple bond. So this is the bond properties. So the number of bonds which we have is 268 bonds we have, and the bond is either rotatable or not, or the bond order, and the start atom of our bond and the end atom of the bond and the length, all the bond properties can be shown or can be viewed in this bond properties icon. And the next one is angle properties. So I have shown you, we will be getting the angles. It may be not clear to you previously, but now you can see in this properties the number of angles which are used in this to build this one is 478 angles have been used here, and the angle length between that each and every molecule is been clearly given here. Few angles are of length 120, few are of 107, 108. Like it is clearly given with what atom, like the angle between the angle length between the atoms, which atoms, like the here the start atom is carbon and here the end atom is hydrogen. So between this two atoms the angle length was 120. In this way you can get the angle properties of the built molecule. And next properties we have torsion properties. So these are the torsion properties between the atoms which we have used, and total we have used 698 atoms in this. And again the last one, properties, conformer properties. So the conformer properties is like we have used this much of energy here. So this is how we get the properties of atom or a molecule what we have created. We can get the properties of that by using this view option. In this properties you can get the options for that. And next here in this build I have shown you this insert, and the next one is here crystallography is there. With this crystallography you can add the unit cells. Here if I click on this, I will go for file, new, sorry, Avogadro. So in this crystallography you can insert this, add unit cell. So this unit cell will be inserted into this crystallography, and You can choose any crystal builder from this. So you can choose any crystal builder, like you can, like this. You can choose any crystal builder in this, and you can click this crystallography. So in this, what happens is, what all cells we have, those cells will have the parameters like A, B, C. If you change this parameters, this make it as all, like I'm changing this parameters 0.3. This is also 0.3. This is also I'm changing to 0.3, and then click on apply. So you can see here the molecular the cell length has been changed. So what is the length we have taken previously? Apart from that, the cell length have been changed, and we can make the modifications, like we can make this row vectors also even. So this is about this crystallography. And the next tool settings I have shown you, and next display settings. So this display settings I have shown you. Next, so this is about the Avogadro tool. So this is a free open tool which we can install, and we can explain this chemistry concepts in a easy way. This is how we can build the atoms and all. This is about one tool. And the next tool is of PHET. So for this also, you need to go to Google and click on Google PHET. So PHET, as soon as you open here, the first thing which you can get, that is that. So PHET, click on this. And in this PHET, here in simulations, click on chemistry. So here all the chemistry related simulations will be opened for us. So I'm choosing one topic, models of hydrogen atom. So I have clicked on that models of hydrogen atom. And now in this models of hydrogen atom, here you can find the different topics related to that. We have here the teaching resources and activities, and even credits will be given to that. So first here you will be finding the different topics related to our area, like to our topic, what we have chosen. In that you can find what all topics will be explained in this. And next, after you've learned this, what are the learning goals which we will gain will be shown here. Now click on this play option. So it will show you the simulations here. So models of hydrogen atom. So this is spectra. So this is the spectra of that. You can see here, as soon as what I am clicking, it is been changing visually. We can explain this. See this. Bohr, de Broglie. See. This is how the simulations has been happening. And next, here we have again that is being explained in 4 simulations. Here you can see. So first it will show you the models of that, and in the next it will show you. So here we can insert like which one we want, which atom suits there, you can insert there. See here, you can insert the atom here. So here we have inserted the red color atom, that is proton. The atom is being inserted here. See here, you can find the visualization of the some model hydrogen atom. So this is explained in the form of a video here. So in this, you can see the visualization of this. 1 minute, it is getting loaded. So, and see here, these are the, previously we have seen the four simulations there. So in that, the red color proton I told you, no? So in this, what is happening according to this Bohr model, according to this de Broglie model, and according to this model, what happens with the help of the simulations, we can explain in this. So this is about a PHET tool, and here we have different again concepts. So I have chosen one topic from the simulations. Even you can search, and it will give you the simulations related to our topic what we have chosen. Here it gave the simulations to the topic to what I have chosen. For that, the related simulation is being shown here. So Rutherford scattering, it has given the simulation. So for this Rutherford scattering, I have clicked on the play button. So this is the Rutherford atom. In this, click on this Rutherford atom. So you can see here the atom, how many protons we have, how many neutrons we have, the energy, minimum and maximum energy, all can be shown here. See the alpha particles with what it has been created, like the alpha particles, if we have, it is clearly explaining you with the help of the visuals. This is again reloaded, and next if you click on this alpha particle, see, traces, I have enabled the traces, so you can see the traces also have this atom has been formed with the help of the traces minimum and maximum. We can change, like we can change the criteria from minimum, what you want you can change according to that. This is this, and the next one is, next you have one more, this plum pudding atom. So here also you can show with the help of the simulations. So these are all the alpha particles. Here what all particles we have used in this, everything will be named clearly with this. I have enabled the traces, and this some the atoms which we have used, the proton, electron, with the different types of symbol, like colors, you can clearly visualize here. So this is about the tool PHET. This is used for interactive simulations. PHET. Next tool is PHET, and the next tool is CK12. For this also, go to Google, give us CK12. So CK12 chemistry, it has been opened. So here you can find all the different concepts with the help of simulations. Here also you can show it in an interactive way, in a play way you can explore, and we can explain this. So here you have different concepts inbuilt. If you don't want this, you can search here, like hydrogen atom, like water molecule, or else water molecule. See here, I've searched about water molecule, so I got related, the structure, like the related, about that, what about my search term I got here, the related terms. So we can explain the help of this. structure of water molecule. Before you go different types of topics. So either you can choose that topic or
Ma'am,
whatever
your
the
voice is
topic.
breaking.
Ma'am, is it okay, ma'am?
Yes, ma'am, it's okay now.
Yes, ma'am. So here you can either go with the inbuilt topics which we have related, like you can search according to the class also, which grade we want, that grade you can search, or else you can search with the topic which you want. You can explore this. It is still loading the structure of water molecule. I have clicked, it is loading. It is loading here, the structure of water molecule. So we got here, see here the structure of water molecule we got. So you can play that, like instead of searching somewhere related to that. So in this particular tool itself, it will give you the brief description about the topic, and as well as it will give you the video, like the video tutorials help, or the practical explanation, visual explanation will be provided with the help of this tool. So it will show you, it is loading, sorry. So this is how we will get the details about that. And here you can see the like the description about that content, what we have, about the keywords, about all, and from what resources we got, that also it will be displayed here. This is about the CK12 tool. So these are all the tools which are used for the AI tools which are used to learn chemistry more easier and in a faster way. So these are all about AI for chemistry. Ma'am, over to you, ma'am. Are there any doubts, ma'am?